Bismillahirrahmanirrahim. Beta, today we are going to start the next chapter, force, density, and pressure. Acha, what is the definition of force? From now on, we won't say it is a pull or a push. We will refine the force as it is rate of change of momentum. Remember, we have discussed it as well. Now, force, density, and pressure. First of all, we will start from the density, then pressure, and at the end, we will discuss the types of and effects of forces. So, first of all, let us move on. Density. What do you mean by density? You see, in your daily life, some objects are even they are larger in volume or they occupy more space, but they are lighter, like the cushions, wood, fruits. But on the on the other hand, the metals, why they are used in gyms for working out, they are heavier. So, what is the difference between them? What makes the things heavier, lighter? That aspect is density. In simplest word, the density means the heaviness of a material. And how do you define density? Density has a symbol of rho, and it is mass over how do we read the divided per unit. So density is the mass per unit volume. Mass and volume. Volume V is capital V, mind it. Mass is the amount of matter or measure of inertia. And volume, how do you define volume? It is the space occupied by an material or object. So density is mass divided by volume, and as both are scalar quantities, so is the density is also a scalar quantity. Scalar quantity are usually only positive. So what is the unit of mass is kg and volume is meter cube. So the unit for density is kg per meter cube. There is one thing which I would like you to remember that will be useful for you if we are knowing the density of a material in kg per meter cube, and if you multiply that density in kg per meter cube, sorry, divide it by 1000, now the density will be in grams per centimeter cube. Like the density of pure water is very cute one, that is 1000 kg per meter cube. And if you divide 1000 by 1000, the answer 1 now will be in gram per centimeter cube. They are equal to each other. Means 1000 kg per meter cube will be 1 gram per centimeter cube. And oppositely, if we are having density in gram per centimeter cube and you multiply it by 1000, it will be converted into kg per meter cube. Like for mercury, Hg, mercury, the density is 13.6 gram per centimeter cube. If you multiply the 13.6 with 1000, the answer will now be in kg per meter cube, right? Clear, beta ji?
Clear.
Sir.
Okay. So this will be very useful, especially now. This will be useful. The conversion in A2 it is used a lot, right? Okay. Now coming to the issue, next question. Beta, if we are given a mixture, like we are given, we are given a mixture where a 60 gram of a liquid which is of density 0.8 gram per centimeter cube is mixed with 40 gram of 0.9 gram per centimeter cube. What do we know? The lighter, less denser will always stay higher, floats, right? And denser, more denser, sinks down. So if it is asked, what will be the density of the whole mixture? Can you answer me, beta? What will be the density of the mixture? Actually, I am hiding the solution. You can share your idea. You don't. It's not necessarily yet that you tell me the answer. How would you find the density?
So do we need to know the volume for that?
Yes, but not given. Then how would you do?
We can find out.
कैसे?
डेंसिटी का फॉर्मूला यूज करेंगे.
Can you give the example? How would you find volume? You are given mass and density.
We multiply the we multiply the mass by the volume, by the density. We
Divide, not multiply. So you are right. So beta, whenever we have to find the density of the mixture, the formula remains same, mass divided by volume. But when it is a mixture, we need to know the total mass divided by total volume, right? Here, we were given masses M1 and M2, so we add them. This is total mass. For total volume, we were not given volume. So formula of density tells density is mass over volume and volume is equal to mass over density. So the first volume will be first mass divided by its density, and second volume will be second mass divided by its density, and plus tells this is total volume, and here plus tells this is total mass. Total mass divided by total volume gives you the density of the mixture. Here is the solution for your convenience, but we are to have common sense, not difficult. Say, let's say sometime three different materials are mixed. This is not only applied to the liquids, it can be applied to the mixture of solid in powder form or in gases as well. So if we mix three different materials of masses M1, M2, we add them, their total to have total mass, and find by using mass over density to find their volume individually, and sum adding them gives you total mass, total volume, right? Sometimes it could be opposite. We are given three like materials where rather than masses we are given volume and densities. Again, our main formula is total mass over total volume. So for total volume we will add the volume straight away. But for finding mass, so density is mass over volume, and mass is density multiplied by volume. So for individual masses, the first mass will be first density multiplied by first volume. Same goes for the second, same goes for the third, and plus means this will tell us the total mass. So beta, I want you to write this whole thing for you. It is a common sense, but if you still write, it will be helpful for you, right?
Okay, sir.
Do tell me better when you are written, when you have written, done, do tell me, please. जी लिख लिया आपने?
yes.
Yes, sir.
फिर ओके. अच्छा बेटा जी, now next point, we are done with the density. Let us move to the pressure. Beta, pressure now comes from the word press. And to press something, what do you need first of all? We need a force. But now, let's say here is a button. You want to press it. What will be the best way to press it? The most convenient. We should apply force like this, or like this. What is the best way?
Vertically downward.
So that is we call perpendicular force. So pressure now is perpendicular force. You know the formula. Let's say you are having this pencil, and what if you press hardly the back of this pencil on your hand, you will feel some pressure. But tell me, if you apply the same force with this tip on your hand, this side on your hand, will your feeling be same?
No, there will be greater pressure.
Why? What is the difference between these two?
The area.
The area. So, what do we see? The larger area will apply lesser pressure. Smaller area will apply larger pressure. So, what is the proportion between pressure and area? They are inversely proportional. On the other hand, larger force will apply larger pressure, so they are direct proportion. So, this tells pressure is directly proportional to the force and inversely proportional to the area. And when we want to convert this inequality into equation, we need a constant beta. This is one of the rarest and perfect formulas where the value of constant is equal to 1. And if you multiply anything with 1, the formula stays as it is. So beta, this is how the formula has come. The pressure is force over area, and we read over as per unit. So force per unit area is the definition. And what type of force we discussed earlier? Don't only say force, it is perpendicular force per unit area. And let me tell you, this word perpendicular is very important. Why? When we will discuss the liquid or fluid pressure, fluid means liquid and gas, they always apply the pressure perpendicular to the surface they are contact with it. This is a very, very important word, right? Clear? So pressure is force per unit area, perpendicular force per unit area. Perpendicular is very important. Now, there is one interesting thing. Force is a vector quantity, has it has a specific direction. So arrow tells vector quantity. Area is also a vector quantity. Like, but amazingly, their ratio, the pressure is a scalar quantity. Right? Clear? Now, what is the unit of pressure? The unit of force is Newton and area is meter square. So its unit is Newton per meter square. And it's quite a long unit to speak. So we have a shorter name for it, that is Pascal. What is 1 Pascal? Is if the 1 Newton force acts on 1 meter square area perpendicularly, then the pressure applied is 1 Pascal. I'm speaking again with a bit of change of words. What is 1 Pascal? If 1 Newton perpendicular force acts on 1 meter square area, then pressure applied is 1 Pascal. This word of this symbol is of perpendicular. So did you know that? This is a symbol of perpendicular. Word perpendicular is very important. I'm telling you again. Right? Should we move on?
So if questions give a force from an angle, then we'll have to convert it to a perpendicular force.
Very right. Rosh, this is a very nice, good idea. You have told it perfectly. So this type of question can come very, very well mentioned or guessed. Now look at the next point. Now the next formula is fluid pressure. Beta, in O level, it was said to be the rho gh is the liquid pressure, but it's not perfectly true. Actually, the gas pressure is also of the same formula. And if we want to mention liquid and gas by a single name or word, that is fluid. Fluid means which can flow. So the formula for fluid pressure is rho gh, whether it is liquid or gas. Both have to apply the formula pressure, and their formula is rho gh. And one more thing to discuss, like gas apply pressure due to collision of particles, so do the liquid. Both the liquid and gases apply the pressure due to the random movement of their particles when they collide with the surface in contact, right? Clear? Now, first point of today, how the rho gh is derived. Today we are going to do its derivation, which usually we do not do in O level. How the formula has come. So, beta, first of all, consider we are having there a container where there is a liquid or fluid. It could be a liquid or gas both of density V, density rho, sorry, and it has a base area of cross section A, and it will be having what do you mean by H? What is H?
Height of the
G nahi. Hassan, what do you
Depth.
mean by H? Depth. Beta, you never say about a swimming pool or a river or a sea that it is very high. The liquids are only deeper. So it's not your mistakes, Rosh, as it has a symbol of H, and we assume the H to be height always. But actual, next time you have to keep this in mind. Here, the H is the depth, and that is taken from the top. We will discuss it inshallah now. And in this formula, the depth should always be in meters. Mostly it will be given in centimeters in different situations. So, first of all, we are having a liquid fluid of density rho, and the container has its uniform one with a base area of A, area of cross section, and the length or the depth of the liquid is H. Saying height technically is not correct. So, beta, what pressure the liquid will apply here? The basic formula pressure is force over area. Now, first point, beta, if you are sitting on a foam, on a sofa or a bed, and when you sit upon that object, the foam is compressed, comes from the pressure. So that is pressed, right? It means you apply some pressure. From where does the force come? When you sit, are you applying force intentionally? No. Your weight actually will be the force which is compressing the foam. What is the formula for weight? mg, right? So this will be your force mg. Now coming to this part, as we know, density is equal to mass over volume, and if we are having a area of cross section container and the length or the depth of the liquid, we multiply by area with the length of the side h, that gives you the volume. So can we write volume as a into h? Is it possible, Sarosh and Hassan?
Yes, sir.
So beta, the volume is a into h. Now ah dividing will multiply on this side. So we can have a formula for the value of mass, rho ah. So what happens? We apply this value of mass here as like this. So G and A will be as it is, but in place of mass, we are substituting its value this one. Right, Beta ji? Clear? What happens? The A will be cancelled by A. So we will be left rho HG. You can write it multiplying in any order. Rho G H saying is very fluent. And whatever we can speak easily, it is easy to remember as well. So beta, this tells the fluid pressure. Let me tell you, this is the formula for both liquid and gas, that is rho GH. Clear? Okay. Now the question comes. Beta, how does the fluid, liquid or gas apply pressure? You see, consider this is a container. How many sides are touching the liquid? This one, and you can see, can you see? The liquid applies the pressure on these sides only, which are in, there is nothing in contact from the top. There is no pressure applied at the top, right? Clear? Will you remember? And one more thing. Can you see all the pressure arrows? They are making 90-degree with the wall perpendicularly. Didn't we mention that liquid and gas always apply the pressure perpendicularly to the surfaces they are in contact with, right? And there is one more thing to remember. As we are going downward, do you see the arrows are getting bigger, bigger, and bigger? Why?
Because depth is increasing and
Very right,
the
very
pressure.
right. Larger the depth. Now, important point. For this one, the depth is this second arrow, right? For third one, depth is always taken from the surface, right? So the deeper we are going, the pressure, the arrows are getting bigger. Can you notice now? Is it clear? Acha, one thing to remember, as we are going deeper and deeper, the pressure increases on the side. So if you would have seen a dam, the walls of the dam are like that. They are thicker at the bottom. Can you make the guess? Because the pressure is will be higher at the bottom now, so the bottom will be thicker. Can you remember? So to sustain that larger pressure of the bottom, near the bottom, the thickness is more for the walls of a dam. Right, Beta ji? Okay. Now, firstly, we were considering the sides of the container where the liquid applies pressure. Now, we are going to discuss Archimedes principle. Now, consider we are having an object, a rectangular object there inside a liquid. So, which side the liquid will apply the pressure? The liquid applies the pressure perpendicularly, and gas as well, to all the surfaces which are in contact with the liquid. So the solid is in contact with the liquid from this side, this side, this side. Two-dimensionally, we can see the four sides. But actually, from all the sides, the liquid applies the pressure. From the right side, the pressure will be towards left. From the left, it will be towards right. From the top, the pressure will be downward. And from the bottom, the pressure will be in which direction you can apply the pressure from the bottom.
Upwards.
That is it. Can you remember? Okay. Now, one thing, all these three arrows I have drawn equal. equal length. Why? What does this show? They all three are equal pressures. Why they are equal? Because their depth is
Same.
same. As you see, we go deeper, the arrows are getting bigger. What does this show? Pressure increases with the depth. And why the arrow at the bottom is largest?
Because it is deepest part
Very
means
right. And
in
largest
more
means
pressure.
that here the pressure is maximum. So the pressure at bottom is always maximum greater than pressure at top. And in which direction is the pressure at bottom? At the bottom, the pressure is in upward direction, and from the top, the pressure is in. So, beta, the upward pressure at the bottom is always larger than the downward pressure at the top. So, which pressure is going to win? The larger one, which is in upward direction. So, it applies an upward force on the object inside a liquid or gas, that is upthrust. So, beta, we are going to discuss Archimedes principle. And what is Archimedes principle? That pressure on the bottom, upward pressure on the bottom is always larger than the downward pressure at the top. So that higher upward pressure creates an upward force which is called upthrust. Where does the upthrust come from? Why is there upthrust? The upward pressure upward pressure at the bottom is larger than the downward pressure at the top. Will you understand, Hassan?
Yes, sir.
So that is why, beta, everything inside a fluid feels an upward force, that is upthrust. Now, one more thing. Rho GH is for fluid, for both liquid and gases. So now let me clear it, beta. Upthrust, not only the gases apply the upthrust. You have to keep in mind the upthrust is applied by both the liquids and gases. What is the evidence in liquid? Beta, if you throw anything from your hand in air, it goes very fast downward. But whatever the thing you drop in water, it always slows down, right? It could be its resistance or friction as well, but the upthrust is involved. How do you feel your weight when you are inside the water? You feel lighter. It means there is something supporting your weight. The upward force is upthrust. But beta, you see the balloons. When the balloon is inflated, it comes very slow. Even if the balloon is filled with helium, rather than going down, it goes higher. So which force is making it move upward? In that scenario, let me tell you, the air resistance is downward when it's rising, the helium or hydrogen balloon. So beta, that is rising due to upthrust applied by the air. Gases do apply the upthrust. The carbon dioxide filled balloon sinks down because it is carbon dioxide is heavier or denser than air, but you will observe still the balloon will be moving, coming down very slow. It doesn't mean that when an object sinks into inside the water is going down or it's going down inside the gas, it's still upthrust is acting on it. Yes, the weight was larger than the upthrust that makes it go down. And here, rising tells the upthrust is larger than the weight. but upthrust works acts anyway. Clear, beta ji? Okay. So let us consider we are having an object. Its top. Can you see this? All the pressures coming from the right side will be balanced by the pressures coming from the left side. So pressures coming from the left side, right side will be cancelled by left side. So we will be left pressure at the top and bottom. Let's say the depth of the top is H1. So what will be the pressure at top? Rho GH1. And depth is taken from the surface of the liquid fluid. So let's say the depth of the bottom is H2. So here pressure will be rho GH2, right? What is the formula? Rho GH for H1, rho GH1 for H2, rho GH2. Right, beta? Clear? So we are having two different pressure. The upward pressure at the bottom and which is stronger and the downward pressure at the top. So whenever we have to find the net pressure, how do we find? Like if we are having two opposite forces, how do you find the net force? The larger force minus smaller force. So net pressure will be larger pressure at bottom minus smaller pressure at top. So bottom pressure was rho GH2, top pressure was rho GH1. Now the net pressure has a formula force over area. But here, as the upward pressure was greater, so the net pressure will be upward now. So the force will be upward. This upward force is upthrust. Right? Clear? Beta, what we are discussing is Archimedes principle. So pressure is force over area. I'm repeating. As the net pressure is upward, because upward pressure is larger, so that force will be upward as well. That upward force applied is upthrust. And formula for pressure is force over area. Now coming to this, we can take rho g common from these two, and this area dividing will multiply here. Area dividing will multiply here. Now consider this, beta, in this diagram. Let's L is the length, and this is H1, this is H2. Can you just imagine for a minute if we subtract H1 and H2? Isn't it equal to the length? Sarosh and Hassan.
Yes, sir.
So beta, we write H1 as H2 minus H1 as the length. So H2 minus H1 will be the length, and length multiplied by area. Isn't it the volume?
Yes.
So beta, this is the formula for the upthrust. But we will elaborate this formula, discuss in detail tomorrow. That is what I wanted to say all for today. Actually, what we have done today is more than what we have